the programming I put high. So there is people can debate on those things, but it's just from my experience, I have put this one. So it's not that it not mean that the others are not less important. At least from start, from nothing, if you say, right. So if you're good in programming and know a little bit on the numerics and model physics, probably you can, for a developer role, that is good to start with. But that's not sufficient. You have to learn a lot after some time, maybe a year or so. And the engineering knowledge is not very important actually for a developer. So that is how it is. And if we go on the support role, it can be two kinds. One is you could be in a software development industry. I mean the CFD software development industry, where you are supporting the developers and the application. It's called application engineer, and you are supporting the customers. So those kind of role. Or you are in a product industry, OEM, and there you could be in a methods role, where you develop methods for doing the product development. So both of the roles, the model physics is very important. It will be more focused on how good we are modeling the physics, or we are getting the results, how accurate, how to do that. And numerics becomes important, and programming is also important in the next level. But the programming is not as same as what developer does. It's more like a user-defined program, supportive programming. That's what we have to do as a application engineer. And engineering, it's okay to have, but being a support, it's better to have equivalent, almost equivalent knowledge in the engineering as well. Though I put low, it should not be low. It should be like close to medium, medium side of low, I would say. And the other role is the design or the functional role, where you are a product working on the product, and so where the engineering becomes the predominant, very high importance. But you, as a part of multiple tools like experimental or analytical or some other low fidelity tools, you have to use CFD as part of your tool. And most likely nowadays the functional role, the CFD usages could be as close as 50% or even more. So in that case, we have to put in solving the model physics and numerics, and programming. It's of low priority. Most of the people doesn't know programming, in fact, but it's good to know some programming for any engineer, I would say. So these are the kind of roles a CFD engineer can take. Can you go to the next one? Yeah. So this is the last slide, and so here I'm going to, how do you start a career in CFD? First, if you don't know anything on the CFD, it's okay. Do some introductory courses which could cover the fundamental aspects of the flow, numerical methods, and how the flow model and the numerical methods are linked. So that is the basic understanding a person should have. And some amount of programming, basic programming is required. So that is the where one can start with. And the two aspects to learn, one is on the programming side. If you are more interested as a developer, then you have to do little more on the programming and start writing some 1D codes or something to understand what is happening. Or if you are more interested on the application side, you have to start learning some softwares, try to solve the problems. So this is how it helps. And this particular course is trying to put a balance on the both side, and so that it just creates a fundamental platform, and then after this you can decide kind of where you want to focus more. So that is the idea. And can you go to the next one? Yeah. So what are the prerequisites for this one? Okay. So my plan is that to cover some aspects of the important mathematics in this one. So if you have a understanding of the UG level mathematics, okay, and fluid mechanics are the one is important here. And during the course, I'm trying to explain those aspects as well. So you should have some understanding on those elements and able to understand the concepts explained in those terms. So that is a prerequisite. And programming knowledge is not really necessary to start with, but definitely after starting, you have to learn programming. So there's no escape from that one. But to start with, there is no such. Don't worry if you don't know any programming. And the most important is the passion and dedication. So that's very important for learning anything, and particularly in CFD, which is you've seen it's kind of a multidisciplinary it cut across the mathematics, computer programming, fluid mechanics. So you might get lost somewhere, and so unless the passion and dedication should be there to drive to reach your goal. Yeah. So I think that's all I want to cover on this one, and probably if we have any questions, then I can answer this.
Thank you so much, Thurayanand, for walking the students an informative session. So, participants, we have been receiving your questions. You can feel free to drop your questions even now. So, Thurayanand, the first question for the day is lattice Boltzmann method is equal to boundary element method?
Okay. So the boundary element method is completely different. Okay. So the boundary element method is the so no, there is nothing on the slide, I think. So it's okay if you don't go back. So the boundary element method is completely different. In boundary element method, we solve the Navier-Stokes equation, but how the boundary is modeled is what different. And there are multiple ways of boundary element methods are available. And so that's the real difference is how do we model the boundary, the wall condition, and what kind of approximation we use. So that is what the boundary element method is. And in case of lattice Boltzmann is completely different. It's more like I wouldn't say Lagrangian, but it's something like we solve like a particle. Okay, solve in terms of particle, like a fluid particle. You are injecting the fluid particle and try to see how they collide and how it moves around. And it's completely different approach. Okay, so it just uses a kinetic theory, and we apply a distribution of particles and see how the particle collides and the resulting force where it moves, and so from there we try to estimate the field data. So that is the lattice Boltzmann method where we use the it's called lattice, and it's not a volume, and try to solve the problem. So if you need more information, right, on these things, it's so the concepts are quite different. That I would say, but exactly if you want more information, then probably we can maybe when we have more touch time, we can look into that.
The next question for the day is, what are the programming? So, are there any programming knowledge required for the CFD domain?
Yeah, yeah, definitely it is required if you want to go into the developer role. But if you are in as a product engineer want to use a CFD, maybe it is not that much, or may not be required also. So, but it's good to have the programming knowledge. And to start with, if you want to start learning, yeah, we have to do some primer on the programming and get some understanding, but it depends on how much. For example, if you're a developer, you should have a proper programming knowledge. You should know the data structures, algorithms, those kind of concepts. If you're doing some kind of very basic level, then not much like MATLAB or Python. is sufficient enough. You not to focus much on the programming aspect. Just do some quick coding and get the results of what you want to do. So that is the level, I would say. So it depends on the role what you are interested in.
Thank you so much, Dayanand. So the next question for the day is, how CFD will impact research in the near and far future?
Okay, so CFD is already impacting the research. Okay, so here I'm not clear what kind of research you are talking about. The CFD itself has its own research, first thing, and so a lot of people are doing research on the CFD itself, how to develop a better model and how to improve the speed of convergence or accelerate the or how to solve in less number of iterations. So a lot of research are going in the CFD field itself. Okay, and if you see how to use CFD for the research, it's almost there already. So people started using CFD for research. So if you want to, for example, whenever you want to do your particular concept, understand your concept, the first thing is people don't go for testing. So those period is over, I think. So the first thing people try to model in CFD. If you want to do certain, understand some particular phenomena, or if you're designing some vehicle and see how much what you can achieve or what can be done on that one. For example, if you're designing a gas turbine blade, and if you want to see how the heat transfer, if you want to do some research on the cooling methods and how to cool different cooling holes, all those things, right? So people use CFD at the first cut analysis, understand what happens, and then try to do an experiment and see what is happening. So CFD goes hand in hand with the research. It's not the experimental, the need of experiment is always there because that is the final proof or the validation. But the percentage of experiments that used for research is going down drastically, and the CFD is started dominating that one. Already it's started dominating. So that's so so that's the current status, and the future it will remain same. The experiment, we cannot get eliminate of an experiment, so it has to be there. But most of the times we try to design the experiments based on the CFD data, and that's what we are already doing in many fields.
Thank you, Raymond. The next question for the day is, why should we use OpenFoam instead of Answers Fluent?
Okay, there is no particular reason for using that. OpenFoam is free to use. It's GNU license, I think it's called. So it means that you can free to use even for commercial purpose. Okay, and the cost is the advantage. So if you're going for Fluent, it's extremely costly. Okay, and the advantage is that you will get a lot of support on the Fluent. So the Answers will support you. That's the only reason. If you're worried about the cost, OpenFoam is the way. If you have a lot of money to spend, Answers, you can go for Answers. The relatively, if you see what are the models available, also there are some differences in the models, and the validation efforts that put on the OpenFoam and Answers are quite different because it's an organization, it's an industry, Answers, and so a lot of validation has been done, and a lot of models are being developed. In OpenFoam, we have a lot of models. So if a particular problem, what you're trying to solve, available in both, then the cost and the or your comfortness in the software. So all those these factors drives you to select. And the primary, I think it's the cost, which drives the selection of software.
Thank you, Jarayanand. The next question for the day is, what are the current challenges of CFD in the field of electric vehicles?
Okay. So, sorry, before that. So, for electric vehicles, the CFD, okay, so the electric vehicle, apart from the engine, right? So here we are using the battery and the motor. So the what I see, I don't have a direct exposure on the electric vehicles, but what I could infer from my understanding is that the heat transfer is the very critical one for the electric. The motor cooling and the battery cooling is very critical, and that's where the CFD will contribute in the electric vehicle. And there are some areas where people are trying to model the batteries in CFD. I don't know exactly how they use, but a lot of battery process, the diffusion process inside the chemical process inside the batteries were also modeled in CFD. And so I think these two are the major one. And a lot of fuel cells are coming. If fuel cells comes, then the CFD in the fuel cells also becomes the other area. Other than this, the other features of automobile between the electric and the conventional, the gasoline one, are same, like exterior aerodynamic stability. So all those things are quite common. So those remain same. The hatchback, the passenger comfortness. So those elements remain same between both the vehicles.
Thank you so much, Dayanand. And the last and final question for the day is, we have a bunch of students who are from different backgrounds. So when it comes to CFD domain, what are your thoughts on the scope in the upcoming years? And how can a fresher start his career in the CFD domain? And if he starts, what will be his growth as a CFD engineer?
Okay, so can you repeat the first one? Is what? Can you repeat the question? I think there are multiple questions in that same question.
So the part one of the question is, what are your thoughts on the scope of CFD in the upcoming years?
Okay, so as I already explained in the presentation, the scope of CFD is going to increase a lot, and it's going to wide in almost all the industries. So many industries started realizing the importance of CFD because the products are getting more and more matured, and quality of the products are getting improved every day, and the productivity and the efficiency of the product has to increase every day because of the higher competition. So all these are driving to a niche design or very effective design which demands CFD. So that's where the industry started focusing to get the competitive advantage. So all the industry which focus on the growth and the competitive advantage, those companies started using the CFDs. And the CFD is still not reachable in the mid scale and the small scale industries because CFD is also a very expensive. And the commercial CFDs, particularly, as one person asked, were OpenFoam answers. If for a company uh, uh, like a big company, for example, a company like Boeing or Airbus. So these kind of companies, a lot of money they can spend a lot, and on the commercial codes and many automobile industries. And if you go into the small scale industries, that's where commercial codes are really expensive. Once you started using, you'll learn how, or you'll come to know how much is the license cost per year for different softwares. And the OpenFoam kind of softwares were used in those industries which could not really spend that much money. Okay, so and because of these softwares, also the scopes are getting increased every day, and many industries have started using, and it also goes into a different kind of industry. For example, manufacturing industries were not into CFD, and now they have started using. The biomedical have started using the CFDs. So lot of such things. There's electronic schooling now. With the if you see a lot of job profiles in Intel and other electrical panel manufacturers, like where they were asking particularly the CFD engineers, right? So for a chip manufacturer, the CFD, nobody has thought about CFD need on a chip manufacturer like 20 years back. But now it becomes it becomes a part of their process and the rules, and so that it's growing. And I think in future there are much more potential industries that can adapt CFD. So with the time it's going to go up, the scope is going to increase. And I think the next question is how to start the career, right?
Yes.
So to start the career, as I already told, you have to start somewhere. Okay, so the first step what you have to take. So don't worry about how to start a career. Just do some course, some learn the books, and so if if you have access to any commercial software, try to use the commercial software or OpenFoam. So you have to do something, and once you start working on that, you'll know that so many things are there to understand and learn. Go and read and take some courses if you want a rapid acceleration to start. If you have a lot of free time, then you can do it slowly by yourself. But if you want to do accelerate and learn quickly, then take some course, uh, uh, get trained by solving the problems. So that is the way actually. So there is no different or special techniques for that. So you have to mix your hand dirty. So that is the only way to learn anything.
Thank you, Dharanand. Thank you so much for patiently answering all the questions from the participants. And I guess I covered most of the repeated questions which were asked from them. So, Dharanand, before we wrap up today's webinar, right, do you have any other things which you wanted to share to the participants?
Um, okay, so I okay, probably I can. So all of you guys are very much interested in CFD, right? So that's why you are attending the course and trying to learn the CFD, which is really good. And learning a skill is really important, at least in the initial part of the career. Once you put the CFD in your resume, then it's going to attract. And also when you're doing the CFD, right, you select the problem what you're solving by targeting the right industry. And so add those kind of problem, the resume will give a lot of value addition. And also it is very, very important to know the fundamentals of CFD, the very basic aspects of CFD to crack any interview. Once you go for the interview, people are going to ask the basic questions, 50%, and that's where the basics becomes very important. And so for that, you have to learn, study a lot. So those are the major things to do. And also try to see if you're already employed in CFD, then you are working, then you have to accelerate your learnings in the CFD. So many people, what I have seen in the industry, will move to some job, start doing something, and later it becomes like they start just repeat the CFD process again and again, do the mesh, run the job, do the mesh, run the job, and I'll get the results and do. And then it becomes more like a robotic thing, and people start focus on the losing the focus on the knowledge part of it, which is quite bad. And after a few years, they feel like they're stuck in the job. They difficult to move out or grow or something like that. So that's why you have to keep on improve your knowledge. Whatever you are doing that, you should know exactly what you are doing and why you are doing. So that's where it becomes very important. And so don't give up the learning. And I think now you are at the right place, and probably it will give you a you'll end up in a better opportunity and start learning and also getting a job or getting a better position in the job. So these kind of learnings and understandings will be very useful in your career.